Hello everyone, welcome back. So in this video we'll see generation of DSB-SC signals. Okay, generation of DSB-SC signals, that is modulation of DSB-SC signals. If you are first time to my channel, please consider subscribing. It will encourage me to do more videos like this. Please subscribe to my channel. So generation of DSB-SC signal is of two types. So there are two types of modulation techniques for generating DSB-SC signal. So first is balanced modulator. First type of modulator is balanced modulator, and second type of modulator is ring modulator. Okay, ring modulator. So any modulator which generates DSB-SC signal, is called as product modulator. Okay, since DSB-SC is the product of both input, message signal and carrier signal, so any modulator which generates DSB-SC signal is called as product modulator. Okay, so in this video we will discuss about balanced modulator only. Okay, so balanced modulator. Right, so in balanced modulators we'll use two AM modulators. So two AM modulators are used in balanced condition. Okay, two AM modulators are used in balanced condition to produce DSB-SC signal. Okay, so in balanced modulator we'll use two AM modulators. So let us see the block diagram of balanced modulator. So it will, as I have told you, it will consist of two AM modulators. So these are the two AM modulators. AM modulator. So let this be 1, and AM modulator, let this be 2. Okay, so they are given with common carrier signal, which is given by AC cos of 2 pi fc into t. Okay, so common carrier is given to both. So for the first AM signal, m of t is directly given. So for the first AM signal, m of t is directly given to the first AM modulator, but for the second modulator it is phase shifted by 180 degrees. It is phase shifted by 180 degrees, and that is given as input to the second AM modulator. So when m of t is phase shifted by 180 degrees, what will happen? So if it is phase shifted, suppose m of t is like this. Okay, so m of t is like this, and if it is phase shifted by 180 degrees, then positive half cycle becomes negative half cycle, and negative half cycle becomes positive half cycle. So this is 180 degrees phase shifted version. Okay, so this is called as 180 degrees phase shifted version. So practical circuit which generates 180 degrees phase shifted version between input and output is CE amplifier. Okay, CE amplifier produces 180 degrees phase shift between input and output. Okay, so what can we write here? This can be written as minus m of t. So the input here will be minus m of t. Okay, so this is called as 180 degrees phase shifter. So m of t is directly given to the first modulator, and it is phase shifted by 180 degrees and is given as input to the second modulator, and the carrier signal is common to both the AM modulators. So the outputs of these modulators are going to be subtracted. Okay, so are going to be subtracted. So this is plus and this is minus. That will give you the output, which is DSB-SC signal. Okay, so the output is going to be subtracted. The output of two AM modulators are going to be subtracted, and that subtracted output will give you the required DSB-SC signal. Okay, so now we'll see the analysis, or we'll prove that DSB-SC is produced at the output of this. So we'll taking this as S of t. This considering it as S1 of t, and this is considered as S2 of t. So S1 of t is the output of AM modulator, which has the inputs m of t and AC cos 2 pi fct. So normal AM modulator output only. So S1 of t is given by AC into 1 plus Ka m of t into cos 2 pi fct. Okay, so this is AC cos 2 pi fct plus AC Ka m of t into cos 2 pi fct. Okay, so this is S1 of t. Now for S2 of t, the second input is minus m of t. So in the place of m of t, here in the place of m of t, we have to substitute it with minus m of t. So it will be AC into 1 Ka into minus m of t. Ka into minus m of t, I can write it as minus Ka m of t into cos 2 pi fct. So this is AC cos 2 pi fct minus AC Ka m of t into cos 2 pi fct. Okay, so this will be S2 of t. So S1 of t and S2 of t are taken as the inputs to a subtracted circuit. So S of t, the final output is S1 of t minus S2 of t. So S1 of t minus S2 of t. So when you subtract these two, so these two terms will get cancelled out. AC cos 2 pi fct and AC cos 2 pi fct gets cancelled out. Okay, and this will be AC Km of t cos 2 pi fct minus of minus AC Km of t into cos 2 pi fct. So you'll get 2 Ka into AC cos 2 pi fct into m of t. So except for a scaling factor, this is a scaling factor. So the output, if you observe, it is again the product of m of t into c of t, which is a DSB-SC signal. So we can say that the output of this balanced modulator is a DSB-SC signal, and hence a DSB-SC signal is produced at the output of balanced modulator. Okay.